This lesson is on the converse of the Pythagorean theorem. So we're going to start with the triangle inequality theorem. To form a triangle, the sum of the two sides must be greater than the third side. So in our diagram here, we usually label the side opposite our angle with the lowercase letter. So for example, across from angle A would be side A, and we use a lowercase letter for the side. Then we have side B and side C. So this theorem means that A plus B needs to be greater than C, B plus C needs to be greater than A, and A plus C needs to be greater than B. All three of these must be true. If these are all true, then the side lengths will form a triangle. And it's very important to remember that we're talking about side lengths, not angle measures. So our first problem says, can segments with lengths 8 meters, 3 meters, and 5 meters form a triangle? So I check my first two. 8 plus 3, is that greater than 5? Yes, it is. 3 plus 5, is that greater than 8? No, it is not, because 8 equals 8. So it is not greater than 8. Therefore, these cannot form a triangle. For the next problem, it says, can segments with lengths 1.8 feet, 3.5 feet, and 5.2 feet form a triangle? I have 1.8 plus 3.5, that is greater than 5.2. 3.5 plus 5.2, that is greater than 1.8. And 1.8 plus 5.2 is greater than 3.5, so yes, those can form a triangle. Then I want to know, can segments with lengths 6.1, 11.3, and 4.2 form a triangle? The first pair works, second pair works, third pair does not. So that means no, I cannot form a triangle here. Okay, so you just have to add different pairs and see if they're greater than the third side. Do that for all three. If it works, you have a triangle. If it doesn't, you do not. Now we're going to classify a triangle by angles using its side lengths. So we're going to basically use Pythagorean theorem here. We're just going to use different signs instead of an equal sign. So if a squared plus b squared, we want to see if that's greater than c squared. So a and b are going to be my shorter lengths in this equation. So a squared plus b squared is greater than c squared. If that's true, then triangle ABC is acute. So as I've highlighted, C is my longer side in the diagram, so that goes on the right side of my inequality. For the next one, if a squared plus b squared equals c squared, we all know what this means. Triangle ABC is a right triangle. Again, longer side is highlighted. If a squared plus b squared is less than c squared, then triangle ABC is obtuse. Okay, so same thing. My longest side here is highlighted in the diagram and the equation. Now I want to classify with these lengths. So first we need to see what is my longest side. I always double check the radicals because they can be a little bit misleading. So 3 square root 61 is 23.43. So that would be my longest side. So I need to set it up in this form. A squared plus b squared, I always do a circle because I'm not sure what sign I'm going to be putting in yet. And then c squared on the right. Remember, c squared is your largest side. So when I plug these in, 15 squared plus 17.2 squared, I have that open circle. And then parentheses, 3 root 61 squared. So 15 squared is 225, 17.2 squared is 295.84. I have that open circle again, and 549. I simplify the left-hand side, and I get 520.84 and 549 on the right. So 549 is greater than 520.84. So that means a squared plus b squared is less than c squared, which means my triangle is obtuse. Now I need to graph the points and then classify the triangle. So first, I have my points plotted and my triangle drawn. I'm going to need to use distance formula to determine the lengths of the segments. So first, I'm doing the distance of xy, so I've put subscripts there so I know what segments I'm finding the distance of. Plug in my points. I get the square root of 1 squared plus 5 squared, which gives me the square root of 26. I'm not going to reduce the radicals for this problem, and I'll explain why when we're determining or when we're classifying the triangle. So my length of segment xy is the square root of 26. Now I have the distance of segment yz. I plug in those points to my distance formula, which for a refresher is x2 minus x1 squared plus y2 minus y1 squared. So I got the square root of 6 squared and negative 2 squared, which is the square root of 36 plus 4, which gives me the square root of 40. So I'm going to label that on my graph. Now I have the distance of xz, so I plug in those x and y coordinates. Simplify, I get the square root of 7 squared plus 3 squared, which gives me the square root of 49 plus 9. So the square root of 58, and I label that on my graph. Now remember, I need to plug this into a squared plus b squared, and then use that c term. So square root of 58 is the biggest length, so that goes on the right-hand side, and now I have the square root of 26 squared plus square root of 40 squared, my open circle, and 58 squared. Because those are all square roots and I'm squaring them all, that just gives me the actual number. So square root of 26 squared is just 26. Square root of 40 squared is 40, and the square root of 58 is 58. So that's why, square root of 58 squared is 58. That's why I didn't reduce my radicals, because I'm just going to be squaring them at this point. If you prefer to reduce them first and then plug them in, that is fine. When I simplify the left-hand side, I get 68. So 68 is greater than 58, which means a squared plus b squared is greater than c squared. So this would be an acute triangle.